Hi, in this video, I will be talking about the normal distribution. The probability density function is shown here with a random variable x. It has a mean of mu and a standard deviation of sigma. The continuous random variable has a bell-shaped probability distribution. Now we're going to be looking at a specific case of the normal distribution that has a mean of 0 and a standard deviation of 1. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. If we put in 0 for mean and 1 for sigma, the probability density function becomes what we have right here. So we see here we have a mean of 0 and a standard deviation of 1. Now the total area under its density curve is 1 and the curve is symmetrical and bell-shaped, just as we see in this curve, in this picture. If we cut the curve across the middle, one side is a mirror image of the other side. Now, for us to be able to standardize our normal distribution, we can go from the normal distribution to the standard normal distribution by using the formula right here. Now, my z becomes the z-score value, where the normal distribution has a random variable x, where my z is the z value or the z-score value. Now, it also implies that we can be able to find our x from the formula we have above. If we multiply both sides by sigma and we add mu to both sides, we can compute x using the formula sigma z plus mu. Next, we are going to look at the following example. The test score across all sessions of a statistics course at a college in Ontario are approximately normally distributed, with a mean of 73.2 and a standard deviation of 10.9. We're supposed to find the probability that a randomly selected student scored below 86. So we want the probability of x less than 86. We are going to standardize by finding the z-score value for 86. So once we translate by using the formula we saw earlier, we have 86 minus the mean, in this case, which is 73.2, divided by the standard deviation, which is 10.9. So this translates to the probability of z less than 1.17. So the probability of x less than 86 coming from a normal distribution, it translates to the standard normal distribution, the probability of z less than 1.17. So we can find this area by using our standard normal table. In our standard normal table here, we have the area below given in the body of the table that is corresponding to a particular z-score value. So on the left side, I will find the number in the first whole number position and in the first decimal place, which in this case is 1.1. Then across the top, I find the number in the second decimal place, which is 0.07. So when I look in the intersection, I'll get 0.8790. So that means the area below the z-score value 1.17 is 0.8790. I can similarly do this by finding that area using Excel. After translating from X to Z, and I use Excel, I go to any cell in Excel and type num.s.dist. I put in that z-score value and then true. It gives me the area below that z-score value, which is the same as what we got from the standard normal table. If we look at what we have in the curve, my mean is at the center. My value 86 is bigger than the mean, so I locate it to the right, and I'm interested in the area below that point, which translates to what we got from our standard normal table and from Excel. So in answer to that question, the probability that they will score less than 86 is going to be the same as this value, 0.8790. Next, we want to find what is the probability that a randomly selected student scored above 59. Here we want the probability of x greater than 59. So we can find the z-score value again by taking 59 minus the mean divided by the standard deviation. But this time around, we want the area above that point, but the table will give us the area below it or the area to the left. So we would have to use the complement rule. So once we find the area below that point, the z-score value of negative 1.3, we subtract that area from 1 to be able to get the area above, which we're interested in. So if we look at that value again in our table, negative 1.3 across the top 0.00, we end up with an area of 0.0968. Then we subtract that from 1 and it will give us the area above, which is going to translate to what we need. So in answer to that question, the probability the student will score above 59 will be 0.9032. We can also express this as a percentage by multiplying by 100. Now, if we wanted to use Excel, after obtaining the z-score value like we did earlier, we are going to take it also to Excel. We use that formula right there. We put in the z-score value of negative 1.30 and then true. So whatever area we have, which in this case is also 0.0968, we subtract from 1 and it's going to give us the area above the point that we need. So if we look at the curve, we'll see that 59 is less than the mean in this case. So we locate it to the left. So the area that we find from the table is going to be to the left, which we have over there. But we are interested in the shaded area, so we have subtracted that value from 1 to get the area that we are interested in, which is above 59. The next question, it says that what is the probability that a randomly selected student scored between 58 and 75? In this case, we want probability of 58 less than x less than 75. When we compute the z-score value corresponding to 58 and 75 using the mean and the standard deviation, we obtain negative 1.39 and 0.17. So the next thing we need to do is to find the area to the left or below 0.17 minus the area below or to the left of negative 1.39. Now we find these areas again from the table. We look at 0.1 on the left margin. Across the top, we find 0.07. We read off 0.5675. Then for negative 1.39, we have negative 1.3. Across the top, we have 0.09, which in this case is 0.0823. Now, when we subtract the two areas, it gives us the area between the two values, which will be the area that we are interested in, which in this case is 0.4852. Now, after finding those z-score values corresponding to 58 and 75, which is negative 1.39 and 0.17 respectively, we can also use Excel by putting in the z-score of 0.17 in that formula and the z-score of negative 1.39 also in that formula. So when we get these two areas like we obtained earlier on, when we subtract, we get 0.4852. If we look at the curve, we'll see that the area below negative 1.39, which is synonymous to the area below 58, is that area right there. And the area below 75, which is synonymous to the area below the z-score value of 0.17, is the whole thing below that point to the left. So the piece between them is just that piece that is shaded that we're interested in. So we have to subtract those two areas that we obtain to get the piece we're interested in, which is 0.4852. Now we're answering the question, if the students in the bottom 3% have to get tutoring, what mark is the cutoff mark for getting tutoring? Now in this case, we have probability of z less than a to be equal to 0.03. In other words, we have a z-score value that we can call a such that the area below that point is 0.03. To obtain that z-score value in Excel, we simply go to any cell and type that formula, norm.s.inv, and we put the area 0.03. It returns negative 1.88. Or we can go to the standard normal table and look inside the body of the table and find the area that is closest to 0.03. In this case, we see it right here. It will be 0.0301. So if we trace it back to see the number on the left margin, negative 1.8, and at the top, 0.08, we'll see that this translates to the same z-score value we got from Excel. Now, when we get this value, we'll see that if we look at the curve, the z-score value corresponding to that will be negative 1.88. In fact, we'll see that that value is less than 0. The 0 in this case is the mean for the standard normal distribution, and it is at the center. Next, we can find x by using the formula we mentioned earlier on. X is equal to sigma times z plus mu. We already have sigma from the question, which is 10.9. We just obtained z from our standard normal table, which is negative 1.88. And our mean also was given as 73.2. So when we compute that, we arrive at approximately 53%. So that means that the students in the bottom 3% will be students that score 53% and lower, and they will need tutoring. Another way to do this using Excel will be for us to go and type this formula in any cell in Excel. Norm.inv. In the first position, I'll put in the area, which is 0.03. In the second position, I will put in the mean, and in the third position, I will put in the standard deviation. So this gives me the result in one step. So it will also give me, to the nearest whole number, approximately 53%. The next question says, if the students in the top 6% earn A in the course, what is the minimum score a student must get to earn an A in the course? Now, in this case, my probability of z greater than A is equal to 0.06. So I need to find a z-score value that will give me the top area of 6%. Again, we always use the table or Excel, which is interested in giving us the area below that point. So by symmetry is also synonymous to a lower area of 1 minus 0.06, which is 0.94. Again, to be able to get the z-score value corresponding to that, I will go to any cell in Excel and type that formula and put in 0.94. And it will return for me approximately 1.55, which is going to be the same as the z-score value corresponding to a top area of 6%. Now, we can also find this from the standard normal table. Now, if we look at the curve, we'll notice that the top area right there is 6%, and the bottom is 1 minus 0.06, which is 0.94, and the z-score value corresponding to that is 1.55. So we use the formula x equals to sigma z plus mu, which in this case is 10.9 times 1.55 plus the mean, which is 73.2. So again, to the next whole number, we have approximately 90%. So that means that the minimum score for the students that will earn an A, that is students in the top 6%, must be 90%. Of course, we can also use Excel. If we go to any cell in Excel and type norm.inv, we put the area in the first position, the mean in the second position, and the standard deviation in the third position. We still get approximately 90%. The next question says, if 40 students are randomly selected, what is the probability they have a mean score that is less than 70? In this case, we're going to use what we call the central limit theorem. And the central limit theorem simply states that if we have a random sample of n observations selected from a population with a mean of mu and a standard deviation of sigma when my n is greater than or equal to 30, that is n is large. The sampling distribution of x bar is approximately normal, with mean of x bar to be mu and sigma x bar to be sigma over square root of n. Now, the larger the value of n, the better will be a normal approximation. So in this case, my z-score conversion will be done using this formula. You notice that my mu x bar is the same as mu, so I still have mu here. But in the denominator, instead of sigma, I will have sigma x bar, which is actually sigma over square root of n. So based on the information we have in that question, my mu x bar will be the same as the population mean, which in the question is 73.2. And my sigma x bar will be sigma, again from the question, sigma is 10.9, and my n, which is 40. So when we put that into the formula, we compute sigma x bar, it gives us approximately 1.723. Then we can be able to find a z-score value that is associated to 70. So in this case, we have the probability of x bar to be less than 70. Notice in the question, you want the probability that we have a mean score of those 40 students. So we have x bar here instead of x. So we have x bar less than 70. And then we use that z-score formula conversion. We already have mu to be 73.2. We have sigma x bar to be 10.9 over square root of 40. When we compute this, we get approximately negative 1.86. So we need the area below that point, below the z-score value of negative 1.86. So again, we just simply go to any cell in Excel. We have num.s.dist. Then we put in the z-score value, comma true, and it returns for us the area we're interested in. We can equally use the standard normal table, and we're still going to get this same area. Thank you so much for watching this video.